So welcome back to the final lesson of the week. In the previous lesson, you learned how to find the value of a floating point number. And in this lesson, we'll do the reverse. We'll start with a value, for instance, a decimal number, and we'll turn it into a floating point number. So in this lesson, we'll briefly recap what we've learned already about fixed and floating point numbers. And I'll teach you a conversion method for turning any fixed point number into a floating point number, and we'll look at some worked examples. So making a floating point number from a decimal number takes two steps. First, we turn the decimal number into a fixed point binary number in the way that we learned last week. And then we'll convert the fixed point to a floating point number. So that one we've done. This one we haven't done yet, so I'm going to do that now. So just to remind you, a fixed point number looks like this. Of course, there isn't really a blob like that floating around inside the computer. The point is just a way of reminding us where the values change from being integers to being fractions. And so the point and the position values are just two ways of giving the same information. Whereas a floating point number is made out of two numbers. The mantissa is the pattern of ones and noughts, and the exponent is the power of 2. And they're both expressed using 2's complement. The point in the mantissa always starts 1 in like that, and then we jump it left or right according to the value of the exponent. So every mantissa has a binary point 1 in from the left. And I don't know if you noticed this, but every mantissa starts 0.1 or 1.0. It always has that pattern. We can use this to help us find the right mantissa. So when we convert a fixed point to a floating point number, we find the mantissa, we hop the point back to where it belongs, and we count how many hops. And the number of hops is the size of the exponent. Basically, we're doing what we did last lesson, but we're doing it the other way round. So every mantissa starts 0.1 or 1.0. In other words, it starts 0.1 or 1.0. Now this is a positive mantissa. It starts with 0, so we're looking for the first occurrence of 0, 1. And so we just play on the mantissa basically. Here it is. There it is. We don't need to include the zeros at the end because they don't have any value, but we have to find the pattern of ones and noughts that makes this number, and the pattern must begin 01 or 10. So there's the mantissa, and now we have to hop the point. So a mantissa always has a point that is 1 in from the start, but the actual place that the point belongs is marked by that blob. So to get the point to the right place, 3 hops. So our exponent is 3. So find the mantissa, hop the point home, and the number of hops is the exponent. So that number is that mantissa and that exponent. You might be told the number of bits to use for the mantissa and the exponent. If you aren't told, you can just use a sensible number that makes it work. Let's do it again. So, can you spot the mantissa in this fixed point number? Remember, the mantissa must begin 01 or 10. Because this whole number begins with 0, the mantissa must begin 0, 1. So there it is. That's the mantissa. Place the point where it goes, always 1 in from the start. How many hops to get back home? 1, 2. The hops were in the wrong direction, but the hops were in the negative direction, and so the value of the exponent is -2. So as a result, this fixed point number with that mantissa, there's the mantissa 0110, and here's the exponent -2. So now it's time for you to try it. Convert this fixed point number into a floating point number made out of a mantissa and an exponent. And let's say you have to create a mantissa of exactly 5 bits and an exponent of exactly 3 bits. So I'm going to just stop for a second now so that you can pause the video and go and do this exercise on paper, because you've got to be able to do these on paper. If we're in class, I'd just say, right, everybody get your pens out and do it. You've got to learn how to do it, because that's what you're going to have to do in the exam. So time to pause the video, get your pen and paper out. So hopefully you've done that, and here's the answer. It's a positive number, it starts 0, so our mantissa must start 0, 1. So there's the mantissa, and there it is. It's a 5-bit mantissa, so the pattern of 1s and 0s is 0, 1, 0, 1, 1. And can you see how many hops to get back home? 1. And it's to the right, so it's a positive direction, so the exponent is 1. I hope you got that. A nice straightforward one, very typical of the sort of question you might have to answer in the exam. And of course, sometimes we have to create a floating point number out of a negative number. And in that case, remember, we're looking for a mantissa that begins 1, 0. So let's have a look at that. Here's another example. Once more, pause the video and go on to the next slide when you're ready, when you've got your answer. So there's the mantissa, and it's 2 hops to get back home. So we've got, there's the mantissa 10010, and there's the exponent 2 hops to get back home. So to recap, you know the difference between a fixed point and a floating point number. In order to convert a fixed point number into a floating point number, you find the mantissa looking for the pattern 01 or 10, and then you count the number of hops to get the point back home, and that's your exponent. So here are 3 decimal numbers. Turn them into fixed point numbers, and then turn the fixed point number into a floating point number represented by a mantissa and an exponent. I've not got any answers here, so I want you to do this before we meet again. This is the last lesson of this week, but we'll be doing more with floating point numbers next week.